All right, so today we're going to look at graphing more than one equation on a graph to see where they overlap. And as we go through this, we have to find the points that are important points for the graph. So based on what we studied yesterday, this would be a solid slanting line because it is x and y in the equation. My slope would be 2 over 1, and my y-intercept would be 2. If I look at my second equation, it's going to be dotted because it doesn't have the equal to line. It is also slanting because it has both variables, and it has a slope of negative 3 over 2 and a y-intercept of negative 5. Now that slope on the first one, 2 over 1, means up to right 1, where my slope on the second one is going to be down and to the right because the top is negative. Now when you graph these, you want to try to think about, are my numbers too big to put it in the center? I don't think so on this one, but some of the times it might be. So first we start off with, you graph this in color. So you put a dot of color next to your equation. So if you want to pause the video, this is a good time to pause it, take down the information about the two lines, and then pick up with the graphing part. Alright, so I'm going to graph this first equation in blue. My y-intercept is 2. I've got to go up 2 over 1, up 2 over 1, up 2 over 1, down to left 1, down to left 1. This is supposed to be a solid line, so I would use a ruler if I could. On the smartboard you can't. Now let's talk about that line. Yesterday we found out that there's above and there's below. This is less than. Where do you think you would shade? Well, you shade below, but you don't put it on the graph, because the idea behind this is if you graph more than one, you've got to look at it in terms of where the overlap is. So now I'm going to graph my second equation in red. I'm going to put my y-intercept here. I've got to go down 3, right 2. Well, I can't do that but once, so I'll go up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. This one is dotted, so I just can do that fairly free-handed. You can put your dotted line up here crossing your blue line. Now, this one is greater than, and if you're not sure which side of this line because it's so steep is greater than, I'm going to choose 0, 0 and test it. So if I put 0 in here like I did yesterday, 0 is greater than negative 5 is true, so I need to shade where 0, 0 is, and that's this side. So when I shade it on my real graph, I only shade the overlap, and I shade it in each color that I've used. Now this intersection of this shaded region only has one good point right here. And that point on this graph is negative 2, negative 2. It does not have any other points. So let's talk about this shaded region. This shaded region is unbounded because as you go this direction, it is not bounded on that side. It keeps going to the right and up forever. That means it can't have a maximum. But when you go towards the left, as I go left, it stops at this point of intersection. There's no more shading. So this is your minimum. When you only have one point, it's either a minimum or a maximum. And there's no math calculations to get that. It's just a well-known fact of what the graph shaded region bounds do. But now when you do other problems, you may have 3 or 4 points, and you may need to do some math calculations, which we'll learn in the second half of these notes. Now on my second equation, I'm going to number 4. So make sure you notice that. I'm not doing number 2, I'm doing number 4. I'm skipping around. The others will be for homework. So here I have a dotted slanting line that has a slope of 1/2 and a y-intercept of negative 4. This is a solid line. It has a solid slanting line because again these all have 2 variables. It has a slope of negative 1 over 1, which we can go back and talk about, and a y-intercept of 3. And this one is also a solid line. It's slanting because it has both variables. And it has a slope of 2 over 1 and a y-intercept missing, so that must mean it's 0. So this is going to go up and to the right, this is going to go down and to the right, and this is going to go up and to the right. So if this would be a good time to pause your video, if you need to copy all of this down. So I have an XY axis. I'm going to plot each one of these. So let's start with the red equation for the first one. It's -4. It goes up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Do it the other direction. This is supposed to be a dotted line. Let's put our dotted line on our rough sketch. And greater than would be above. So on our next equation, I'm going to put a green dot. So I'm going to plot my y-intercept at 3. I'm going to go down 1, right 1. That puts it on the diagonal of each of these squares, so it makes it really easy to count. You don't even, once you get the pattern going, you just go to the corner of each square. This is a solid line. Doesn't look like it crosses at a good place. And less than would be below. And then on this third one, I'm going to do blue. Y-intercept is 0, up to 1 over 1, up 2 over 1, down to left 1, down to left 1, down to left 1, down to left 1. This is a solid line, so using a ruler would be very important, but I can't do that. It's got to cross the red and the green line. That looks a little vertical, but I can't really fix that because I didn't make my red line at the right slant. And less than is below. Well, that doesn't really help, so let me try to do that again. Okay, now it slants better. And below. So it's actually in here. So we put all 3 colors in there. You want your rough sketch to be as close to the slant of the lines as you can. So I have 3 points of intersection. One is here, one is here, and one is here. And this one is at 1, 2, is the only one that looks like a whole number. The others do not look like whole numbers at all. So how do I get the solutions? Well, for where the red and the green line cross, I could set negative x plus 3 and 1/2 x minus 4. I think I'd put the 1/2 first. And I would solve that. You can move your x's over and get 3/2 x minus 4 equals 3. Then you can add your 4 to the other side and get 7 and flip multiply. And that makes x equal to 14/3. So that's this point, 14/3. Now you've got to go back and choose one of your equations to plug it back in. I chose the green one because it just has a negative on that number. And I have to add 3 to get my y value. And this is the same thing as 9/3. So if I add those together, I get -5/3. For the last point that I'm looking at, I've got to see the blue and the red lines cross. The blue line was 2x and the red line was the half one. So I would set 2x equal to 1/2 x minus 4 because it's bigger. That would be important to put that first. If I take a half away, I get 3/2 x equals -4. And if I flip multiply, I get -2/3 times -4, which is -8/3. Now to get the y value for that, I choose one of the equations. I purposely would like to do the one with the y and 2. So if I put negative 8/3 in for x, that would make negative 16/3. So just like before, when we did lesson 3.4 with the nonlinears, you can set two linears equal and solve and get x, and you can plug x back in to get y. And one of the reasons, again, that you have to do it this way is because your state test now is going to be calculator active and inactive on Math 3, and so you need to be able to do it by hand as well as with Desmos. All right. So in our next problem, we're going to do this one after lunch, so I'm going to pause the video. That gives you time to get caught up. All right, so before we went to lunch, you wrote down what you thought these was. A parabola that's what? Dotted. And then on this one, you said horizontal line, dotted or solid? Solid. Oh, you said solid. I'm writing dotted. Solid line. So for this one, you have a y-intercept of 4 because that's the only thing you have is all 4s, right? For this one, you have to make a table. So we might want to talk about when you do things by hand sometimes, y'all, it kind of leaves it to, well, what do I need to do if I have different formats? As long as you don't have an x term in there by itself in the middle, this is vertex form. If you have ax squared plus bx plus c, you got to know how to find the vertex because you can't get that like from just looking at it. We talked about that yesterday. Yesterday we used a calculator. Sometime we might need to talk about how to do that by hand again. But this one we can't. Because this is in parentheses. How much left or right did it go? None. And it went 3 down. So our vertex in this problem is 0, negative 3. Now, if we think about this without a calculator, that would be the value. Wait a minute, I'm off one. I put it in the wrong box. That would be the value that goes in the middle of your table. It is not impossible to hand calculate that. You do not actually need a calculator to get some points. You just plug in points and get them. But it's important to know that that point's the one in the middle because it's the vertex. So I need 1, 2, and 3, and I need negative 1, negative 2, and negative 3. If 0, negative 3 is the vertex, then the top 3 will have the same answers as the bottom 3, and it's not difficult to get the bottom 3. Because I can go 1 squared minus 3 is 1 minus 3 is negative 2. If 1 is negative 2, so is negative 1. Because of symmetry. 2 squared minus 3 will be 4 minus 3 is 1. So 2 is 1, and so is negative 2. 1. 3 squared minus 3 is 9 minus 3 is 6. So that means both of the 3's are 6. That's what symmetry is all about. You only have to calculate 3 points and you've got the other 3 on the other side of the vertex. That does not work as well when you have x squared plus 3x plus 5, for example, because you can't get the vertex out of the formula. But we may learn some stuff later that we maybe could do that. All right. So now that we have everything we need, let's look at our numbers. 6 is the biggest thing we have. So this graph, if we put it in the middle, will be at 8. Maybe we should come down just a hair to have more up. And put our x-axis down a couple of lines to give us more up, to have more for that parabola going up. But we can put the the y-axis in the middle. So when you graph your parabola, for example, again, we're putting our color dot over here, so we know that our whatever color you're using is for the parabola. You'll just plot these points. Now, I always plot the points on the right and flip them to the left. You can plot all 7 of them individually if you'd like. But I always start with the center one at 0, -3. And since that's the center, that means the y-axis is the middle. And how far it is from the y-axis will do my symmetry. So if I do 1, -2, then I can go 1 away on the other side and put my -1, -2. If I put 2, 1, go over to 2 up 1, that's 2 away from the y-axis, so I'll come across and do 2 away from the y-axis on the other side. If I do 3, 6, over 3 up 1, 2, 3, 4, 5, 6, that's 3 away from the axis, so I go 3 on the other side. You don't actually have to plot the ones on the other side as much as just count how far they are from the axis of symmetry. So now this was supposed to be dotted, right? And if I look at my rough sketch, I've got to decide, do I shade inside the parabola or outside? Should we test 0, 0? It's inside. Okay. So if I put 0 here and 0 here, that'll be 0 is greater than -3. Is that true? Is 0 bigger than -3? Yes. So on our rough sketch, we'll shade inside for our parabola being greater than. Now for the horizontal line, that seems pretty easy. Just go through the y-axis at 4. So we can put our dotted color on our equation. Draw a horizontal line through 4. Solid. Everybody agree with that? That's easier than drawing the parabola, right? Then we draw a horizontal line across our parabola up here and decide if it's shading up or shading down. Down. Is my region bounded or unbounded? Bounded, because it's inside this parabola and the top of it is being cut off by that horizontal line to make it bounded. So since it's bounded, that kind of sounds like we'd have maxes and mins that we could calculate. How many points of intersection are there? 2. Do they look like whole numbers on yours? Anybody think they're whole numbers? No? I know one thing. Y is 4. I do know that, right? By looking at that point, I can tell the y is 4. The only thing I can't tell is what's x. Does everybody agree with that? All right. So I know, when I look at it, that this is going to be a negative number with 4, and this is going to be a positive number with 4. In fact, not only do I know that, but I'm pretty sure they're opposites of each other because they look equal distance across the across that line, do they not? From the y-axis. Doesn't look like one of them like would be, 2 and -2 as an example. They'd be opposites of each other, whatever it is. So if I can get the positive one, I know what the negative one's going to be. So I have these 2 equations I can set equal to see where they cross. So I set x squared minus 3 equal to 4. You always set your 2 equations equal when they're in y = 2 form. You set them equal to see where do the x's cross. So I add 3 to both sides. I take a square root to get rid of the square, and this is where the 2 answers come in. When you square root, you're supposed to put a plus or minus on your square root. That's why they're the same number, but just one's positive and one's negative, because you took a square root, and they're equal distances from the y-axis, so that's why. So this one is negative square root of 7, and this one's positive square root of 7. Now, if I used Desmos to get this answer, it would have been some awful decimal that I couldn't get the exact answer for. And on the state test, I don't know if they're going to write decimals or not decimals on the non-calculator part of the test. I would assume they'd write exact if that was what they were looking for. With calculators, we probably would write decimals. But not necessarily. You might have these answers, and you might have to turn them to decimals on the calculator active to match up to your Desmos. I'm not going to find the maximum or minimum on this problem because it's bounded, and I'd have to have an equation to calculate it because I have more than 1 point. I can only figure out max and min from the looks of the picture if it's unbounded and I only have 1 point. So we'll talk about that in the second part of the lesson, though. We are going to look at that, but not on this one. All right, we're going to look at one more of these. This is number 9. And after we look at number 9, I've got to pass out the last page that goes with this packet that you didn't get yesterday because I didn't have time to type enough. And we'll look at a few examples off of it. All right. So in this one, what kind of equations do I have? A circle and a quadratic. This is a circle equation. Will my circle be solid or dotted? Solid. Let's talk about what you use to graph a circle. What did we talk about yesterday are the 2 important things it takes to graph a circle? Right, the center, because that has to be perfect. And what else? The radius. All right. Now, normally there's parentheses right here that the square is on. This says how much it moved up, down, left, or right. How much did mine move? None. So that makes 0. It didn't move left or right. It didn't move up or down. It stayed at 0, 0. The radius is the square root of this number on the end. In this case, it's 3. Technically, wouldn't that be plus or minus 3? Would that have anything to do with why I go up 3 and down 3? Left 3 and right 3? Absolutely. All right. This is our parabola, solid or dotted? Dotted, okay. Can I get the vertex from that format? Yes. Because I can make it into this. There's no middle term. The only time you can't get it from this is when there's a middle term that's linear. As long as I only have a quadratic and constant, it's easy. So this one again happens to be an easy number, 0, negative 1. We can calculate 1, 2, and 3, and that will give us negative 1, negative 2, and negative 3. Now sometimes that x might have x minus 1 on it. And if it has x minus 1, then I'll be looking at 1 for the x and getting 3 numbers on each side of 1. I don't have a parentheses, that's why it's 0. So 1 squared is 1, minus 1 is 0. 2 squared is 4, minus 1 is 3. And 3 squared is 9, and minus 1 is 8. So in this case, it looks like I need a lot more positive than I need negative. So maybe we should move the x-axis down a little bit and not put it in the middle of the picture, but the y-axis can be in the middle. So we have enough information. I hope I didn't go down too far. Y'all got more than 3 at the bottom, right? Got more than 3 lines at the bottom? Everybody good? Because I got to go 3 down. So you'll be careful when moving it down. Don't move it too much. So we're going to start off with our circle formula. So put your color dot for circle. We're going to plot our center, and we're going to count up, 3 down, 3 right, 3 left, 3. So we put our center in and come out 3 in all directions. This is supposed to be solid. It's a whole lot harder to draw a solid one, but do the best you can. So when we look at our rough sketch, we've got to decide if it's shaded inside or outside. Would 0 be a good number to try since it's inside? So 0, 0, unless you're really close to it, 0, 0 is always the best point. So if you plug zeros in here, won't that make it 0 is less than 9? Is that true? Then we're going to shade inside. Now we've got to draw our parabola and see what it does in relation to our circle. You know, it might cross it 4 times. It might cross it twice. It may just be sitting on the edge of it somewhere. Until you draw it, you don't know how many intersections it could make, but at most it could be 4. Think about that, right? At most it could come down and go through it twice. Well, I guess it could touch maybe 5. No, 4. 4 is the most. So, we start with 0, -1. We're going to plot on each side as we go because this one's split over the y-axis again. So 1, 0 is an x-intercept. So there's one over here at -1, 0. 2, 3. If I go over 2 and up 3, it looks like it's outside. Go over 2, up 3, it looks like it's outside. And then 3, 8. Go over to 3. 1, 2, 3, 4, 5, 6, 7, 8. That's 3 away from the y-axis, so go 3 away from it on the other side. This is dotted. So for right now, we know for certain that our shaded region is going to be inside that circle. We just don't know which piece inside the circle, right? Everybody agree? We've got to check out which piece, and since 0, 0 is inside the parabola, that would be a good point to test 0, 0, and that'll tell us if we shade inside the parabola or not. So if I put 0 in here, is it true or false? False. So that means that I don't shade in there. That means I shade out here. Everybody agree? So I'm inside the circle, but the bottom half of it. I'm in here. So 0, 0 becomes a really important point to check. And it works on 90% of the problems. There's just once in a while it's either too close or it's on it, and you can't use it if it's on it or too close. So how many points of intersection did I get? 2. Do they look like they'd be opposites of each other? So if I get one of them, don't I have the other one? All right. So I have a point of intersection in these 2 places that definitely do not look like whole numbers. So we're going to try working with this. Now, they're not both in y equal to form. That might be a little problem, wouldn't it? When you don't have 2 of them in y equal to form, you want to take the one that's equal to y and substitute it for y. Now, you're not doing greater than and less than right now. When you're solving for the points, you're solving equal to. Don't put greater than, less than signs in there. So I took the y out and put in what the y equation was. And this tells me either I can do this by hand or not really quickly. If I square that, am I going to get a quadratic? X squared squared, is that a quadratic? If you square a square. No, it'll make a 4th power, won't it? Think about that. If you square a square, don't you multiply the powers together? So that means I'm at this point in this class might not have enough skill to solve that one by hand, because we haven't solved 4th power problems this year already, right? So you need to use your calculator or Desmos to get this answer, and either way it's going to be a decimal because we can't do it by hand. Okay? Now, take a minute or 2 to put that y1, y2 in your calculator and just try that, and then I'm going to hand out a piece of paper for the last part of our lesson. Alright, so you're telling me that when you did y1, y2 with this equation, that it told you about 1.84, 9. But it's obvious that the y value here is not 9, because that doesn't have anything to do with solving this point. That has to do with solving for x. So you throw that y value away, and you get this. Then you quit. That's second mode, right? Yes. and you type x squared minus 1. And what it does is it puts the whole decimal for this in there, squares it, minuses the 1, and gives you the answer. Because when you do second calc number 5, enter, it stores that x and y value in case you need to use it to do other calculations. And so when you do that, what do you get? 2.37. Now let's look. Over 1.834 up. Well, that is up 2 point something, isn't it? So that answer makes sense. So on this side, it's 1.84, comma 2. What did you say? 37. All right. On this side, it's negative 1.84 up 2.37 because it has symmetry. Does that make sense? All right. Now, next part of our lesson, we're going to go to the sheet that I just passed out to everybody. Now, I'm going to take a little shortcut on this sheet because I want you to see a little bit of something that can go a little faster, but at the same time, I want you to be able to see what would you do with these numbers if you had them. Okay, but we're going to get them a little quicker. So you'll notice I didn't put any graph stuff on there. Right? We're going to use Desmos to get the points so you can see what do you do with them after you get them. So we're going to do number 1. So everybody needs to get their computer out. Now, what makes this different, y'all, and this is important, you have to type all of the equation in. You can't just type what you want to in. You got to type it exactly how it looks. Okay? So if I was working with questions that I needed to graph, and I needed to know those points fairly quickly, I could use Desmos to get them quickly. So the first half of this equation is going to be based on what we just talked about. Constraints are the sides of the shaded region that binds it together to be either bounded or unbounded. That's what constraints are. You are not typing the objective quantity in your calculator or in your Desmos. That is the new part I want to show you how to do. But we're going to graph it on there to make it go a little faster. So everybody type these two equations in totally in your Desmos. The greater thans, the less thans, the equal marks, all of that, the y's, the x's, everything has to be typed exactly how those appear. And we're only going to probably have time to maybe look at 2 of these together today. So then we'll see what we can do after that to talk about where we're going tomorrow and what you need to do tonight. Alright, so everybody's typing both equations in. What I do want on here is a rough sketch of what the lines do. So for example, one of them's positive, one of them's negative, right? So you can look at your calculator screen and say, okay, here's my positive one, it's doing this, and which way is it shading on your screen? Down? Okay. And then you'll look at your negative line. You got a line going downhill, right? And is it shaded above or below for that one? Above, right? So when you look at it, do the 2 colors mix to make this section right here? Everybody agrees. Is it bounded or unbounded? Can you tell from your computer? You should be able to. Is there a stopping point over here? Because if you can move it over and still see color, it's not bounded, is it? So this is an unbounded region, which tells me that I'm not going to get a max and a min. I'm just going to get one of them. Which one am I going to get? Because it's unbounded on that side. I'm going to get a min. Now, where is that point? On your computer, you should be able to click on the intersection and find the point. All right, negative 2.4, comma, negative 1.8. Not very nice numbers, but oh well. Aren't you glad we're using Desmos? All right. No, so what I want to show you is, if we had just graphed all of that by hand and found all those numbers like we just did on the previous questions, I want to show you what you can do with those numbers to actually talk about maxes and mins. Okay? This objective quantity equation is an equation that calculates the value of that max or min. This is the point that makes the minimum because it's unbounded and keeps going up forever. It doesn't have a maximum, but this is a minimum. The answer to the question is, what is the value of your minimum? So you plug in your point into this equation and work out the value of your minimum. Now, in a word problem, that would really mean something. These numbers don't mean much, but it is the value. And the objective quantity equations change from problem to problem. It is not always the same equation. So what is this minimum value that we're getting? Negative what? 5.4. Is everybody getting negative 5.4? So that point makes a minimum value of negative 5.4. Well, it makes sense that it's a minimum because it came out really small, didn't it? If I had more points, I would have to choose which one is the biggest and the smallest, but I only have 1 point, and it can't be the maximum because it's unbounded. Everybody with me? All right, we're going to look at one more. We're going to look at number 4 because I'm short on time. I was going to look at number 2, but I think it would be better if we look at number 4. If I was graphing this by hand, I want you to listen to this because you might have to graph one like this by hand at some point in time. What would a between mean? It doesn't mean color between on a number line, does it? What kind of line only has an X? Vertical. What would a between sound like if you got a vertical? You'd have 2 of them, wouldn't you? And where do you think you'd color? In between. Exactly. You can actually type that on there. It doesn't make you do an and. You can actually type this whole thing in and get it. But I'll tell you up front that the 2 vertical lines are this one. Only a Y in it makes 2 horizontal lines. And if you're between all of those, aren't you going to be in the center of the tic-tac-toe? And then when you put this one in, it's going to divide that tic-tac-toe board up into 2 sections, and you'll know which one to choose based on which one's colored in more. So put it all in so we can see where to put the slanting line, because we don't know where to put it. On our rough sketch here, we don't know where to put it, but we're pretty sure it's going to cut our tic-tac-toe board up in the center, because if I shade, this was shaded this way. This was shaded between because that's what they're called. We just got to figure out where that line goes to see the rest of the shading. And I'm going to pause the video while you do that. All right, so when you drew your graph, everybody agrees that this top triangle here that I've drawn in black has 3 corners that touch the darkest shaded area on your picture, right? Those 3 corners are the points. We don't know if they're maxes, we don't know if they're mins, but it's bounded because it's cut off on all 3 sides with the shaded region. So that means I need to know where those 3 points are. And I'm going to list them over here. Woo! Wow. Let me try that again. So click on it and let's find those 3 points. Where is this point right here? Let's do them in order. Everybody agrees? Negative 2, 3. All right. Where's the one straight across from it? 4, 3. Well, that makes sense. They'd have the same Y because they're on a horizontal line, right? Where's this one down here? 4, negative 1. Well, that makes sense because they're both on a vertical line. Everybody agree? That's why the X's are alike. Now, I don't know which ones these are maxes or mins. So when you get more than 1 point for maxes or mins, that's what this formula is going to help you figure out. You're going to put each point into the formula. I changed all the x's to the x in each one. I changed all the y's to the y in each one. You calculate them all up. Whichever one has the smallest answer is the minimum. Whichever one has the largest answer is the maximum. And the other one, we don't care about. All we want is which one of these has the highest and lowest number. All right, everybody calculate those up real quick. Don't call it out. Just do it yourself. Calculate. This is called objective quantity. It helps you to figure out who's got the biggest answer and who's got the littlest answer. So if I had had formulas on that other page that we were doing all the graphs by hand, if I'd had the formulas on there, we could have calculated up all the maxes and mins for all those problems. I wanted to focus on graphing on that because I wanted you to see how to graph and find those shaded regions. I'm focusing here more on get the points off the computer, how do you calculate them and what do you do with them, because you should be able to do all of that. So, what are you getting for the first answer? What are you getting for the second one? What are you getting for the third one? 18. So this is the min, and this is the max. Now, I want you to be very, very careful. Students miss this all the time. This point causes the minimum value of negative 14. The value is the minimum. This is the point that causes to have that minimum. That could relate, if this problem is about cost or profits or anything like that, it could relate it to real life. Let's say it's profits. It'll make more sense. I'm in the hole $14. Do you want to be in the hole $14? I made $18 at the most with whatever my problem's about. So if I'm making bracelets and selling them, with this point, I'm in the hole $14. I don't think I want to make a minimum profit, do you? I'd want to make the maximum profit. So that's how it can relate to a real world problem. The number is the actual min or max. These are just the points that cause it to happen. Okay? So, on each of these questions, what I'm asking you to do is kind of do the back end of it without actually doing the hand graphing. Does that make sense? On the other part of the lesson, I'm getting you to practice your hand graphing so we can put the two concepts together and maybe have maybe a couple of problems on a test where you do the graphing all the way out, plug them in and get the values and tell me what the max and min is. But to let you practice both ends, I thought it might be better to practice a lot more graphing than it is plugging numbers in. And that's why there are only 7 of these and there's more of the practicing graphing. Okay? Now, if you run across something on the graphing that you can't hand calculate, you can put it in your calculator to see where it crosses, but be real careful. There are a lot of those you can hand calculate. Okay? Now, let's talk for just very quickly. What do we need to have done by tomorrow? I would like those 7 problems that you're using Desmos done. The ones I just showed you, the last 2, you've got 5. Can you have those 5 done by tomorrow? Then on the other 2 pages I gave you earlier, if you could have the linear ones done. The first few on there are all linear. If you could have the linear ones done, then we could do the ones that are harder to do in class because you'll have more questions about them. Now, somebody, I got one right here. So that would mean that you probably could do 1 through 4. I did 1. I did 4, so guess what? That gives you 2 more. You could have 2 and 3 done on this page, and 1 through 7 on the other page, and we'll do the quadratic circles ones in class tomorrow. Are we good on that? Now, I'm going to talk just a second about word problems. The last question on the word problems is incorrect. I was having one of my moments where I reversed numbers and I put the 20 and the 30 backwards in the problem. If you turn the 20 and the 30 around, it'll work. It was supposed to be 30 income, 20 for cost, and I told it the other way around, and that doesn't have an answer. If you try it with 30 for income and 20 for cost, it will work on the last question. Now, tomorrow our focus before lunch will be about word problems, if you need more help with that. After lunch, we will work on this graphing, okay? We'll also talk about what's on your test, and I'll pass back some work to you, okay?